Let's go ahead and look at how to sketch a graph of 1/2 of 5 raised to the negative x. Again, we're going to do this with the strategy that we've seen before, and we're going to graph this step by step. So we can go ahead and sequentially look at the transformations. Our function f of x, before we apply the compression of 1/2, is going to be 5 raised to the negative x, and before we do that, this is going to be 5 raised to the x. And so we're going to graph first our original function, then we're going to graph our reflection across the y-axis, and then in step number 3, we'll finally graph our last function here. Since we have a base greater than 1, our graph is increasing. And 2, with the reflection across the y-axis, this is the same thing as 1/5 raised to the x, which means that our function becomes decreasing. And finally, we want to multiply this by a 1/2, so all the y values are going to be divided by 2, which means for graph number 3, our graph is going to look something like this, where our y-intercept now is the point 0, 1/2. Let's work on another problem where we have to practice sketching the graph. Here we're given the function f of x is equal to a negative 7 times 2 raised to the x plus 2. And we're going to go ahead and just, number 1, rewrite this equation. So we'll get y is equal to a negative 7 times 2 raised to the x plus 2. And then we're going to take off step by step the transformations. So first remove the plus 2, and this is equal to a negative 7 of 2 raised to the x. And then take off the negative, and we're left with a y is equal to a 7 times 2 raised to the x. And then take off the 7, and we're just left with a 2 raised to the x. So we'll go ahead and sketch each of these graphs. So number 1, we just have our regular graph here. This is an increasing exponential function. And the graph of such a function looks something like this. And then for number 2, this is given to us by a vertical stretch. And so all our y values are being multiplied by 7. Which means the shape of our graph is about the same, but the only difference now is, again, all the y values have been multiplied by a value of 7. And so one example is that our y-intercept is now the point 0, 7. In step 3, we go ahead and we flip number 2 across the x-axis, and this is going to give us a graph that looks something like this, where our y-intercept here is now 0, negative 7. And then in step number 4, we're going to shift our graph up by 2 units. Oops, sorry. So that our y-intercept now is at the point 0, negative 5, but our graph is now crossing the x-axis. Now that we've recalled how to sketch a graph of an exponential function using transformations, let's look at the opposite direction. Suppose we're given a graph. What we want to do is we want to find an equation that represents the corresponding graph. Now recall that the general equation of an exponential function is given by y is equal to an a times b raised to the x. And the thing that we notice is that our horizontal asymptote has been shifted up by 9 units, which means that our graph has a vertical shift by 9 units. So go ahead and add a plus 9 to this equation here. Now that we have our equation, what we want to go ahead and do is we want to use the points given, the point 1, 3, and 0, 7, to figure out what our a and b are. So let's go ahead and start a new page. And on this page, we just have the information from the previous page. We're going to plug in the values for 0, 7, and 1, 3 into our equation. This will give us 7 is equal to an a, b raised to the 0 plus 9. And the other set of information is going to be 3 is equal to a times b to the first plus 9. Simplifying our first equation, we get 7 is equal to an a plus 9. And simplifying the second, we'll get 3 is equal to an a times b plus 9. This first equation tells us that a is going to be equal to a negative 2. Now plugging in negative 2 to our second equation, this gives us 3 is equal to a negative 2, b plus 9. Solving for b, this is going to be a negative 6 is equal to a negative 2 times b, which leaves us with 3 is equal to b. Therefore, plugging in what we found to our original equation, we'll get y is equal to a negative 2 times 3 raised to the x plus 9.